Hello.
That was Mr. Butterfield. He wanted to say hi. So I'll keep going. This last one here, we have 3 times 0.5 to the x power. So the x there is an exponent, so that's going to be exponential. Okay? So when it's a little x, it's going to be exponential. When it's a regular x without an exponent, it's going to be linear. And then as we see down here, these are all quadratic because they will give us x squared. So like I showed you in the kind of definition of quadratic, this is going to be quadratic because it's in factored form. So if we were to multiply this, we would get x times x, which would give us x squared. If we were to take the exponent of 2 and distribute it to everything that's inside the parentheses, that would also give us x squared. And then here, obviously, it says x squared, so we know it's quadratic, okay? Another thing too, if you're not sure how it'll turn out, you can always take this and plug it into Desmos. So I don't know if this will let me copy and paste it, but let's try it. So if I take this, let's see, and I'll go ahead and paste it into Desmos. So as we can see, that gives us a parabola, so we know a parabola. Our notes tell us parabolas are quadratic, okay? So if you're ever stuck with an equation, you can honestly just plug it into Desmos, and that should help you. And the last thing is tables, and tables are something that I wish I could show you in person. We've done a little bit of this in the past, but when we look at tables, we're only looking at the y column, okay? So we only really care about the y column. And we're looking at what's the difference between each part. So some of you are good at looking at this and knowing, oh, I can tell right away we're adding 2 each time. Some of you might have to use your calculator and you might have to go and do the second number minus the first number, the third number minus the second number, and so on, and just see what the pattern is. So if we have 2, 4, 6, 8, we're adding 2 each time. So when you're adding the same number each time, the very top tells us when you add the same number each time, adding is going to be linear. Okay, so we know that this first table is going to be linear because we're adding the same number each time. Okay, this next one, again, we're only looking at the y column. And, oops, we go 2, 4, 8, 16. So we're not adding 2 each time. We're adding 2 to get 4, but 4 plus 2 would be 6, and we don't have 6 here. So we're not adding 2. Let's see if we're multiplying. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So we're multiplying by 2 each time. So when we multiply by 2, or multiply by the same number, multiplying gives us exponential, okay? So we know that that middle table is exponential. And then the last one, a way that you can think about it is if it's not linear and it's not exponential, it's probably going to be quadratic, unless it's going to be neither. But if we look at this, and this is where I wish I could write it on the board a little bit more, but if we look here, we go from 15 to 24 to 35 to 48. So if we do 24 minus 15, we get 9. So we'd have a little plus 9 right over here. If we do 35 minus 24, we get 11. So it goes by 9 plus 11. And then if we do 48 minus 35, we get 13. So we went 9 plus 11 plus 13. So we're not adding the same number. We're not multiplying by the same number either. But if we looked at the second difference, so the difference between 11 minus 9, that gives us 2. And then remember we had 9, 11, 13. So if we did 13 minus 11, that would also give us 2. So in this case, the second difference is the same. If the second difference is the same, it's going to be quadratic, okay? So again, that one's a little bit trickier. Don't stress about that too much. So you can definitely use this video and the notes to help you. For this week's practice, I actually have, it's a pretty large, like, I guess, packet or document, but I'm not asking that you do all of it, okay? In fact, I actually don't want you to do all of it because I didn't show you how to do number 3, or the objective 3. I didn't show you how to write a function or for a pattern. So right now I just want you to identify, does it represent a linear, quadratic, or exponential function? And how to do that with equations and graphs and tables. So there are several examples here. I'm only asking that you do 10 of them. So you choose 10 to do on your own, okay? So here is 4 right here. You can do this by looking at the examples that we have in our notes. So for number 1, we have x here is an exponent. So we would look back at our notes, and it tells us that if x is an exponent, it's going to be exponential. Okay, so for that one, all you'd have to do is write exponential. So if you could go through and just choose 10 of these that you think you could do. If you're more of a visual person, you can do the ones that have graphs. There's some equation ones. Okay, you don't have to write a function for it. So a function rule. So for this part, don't worry about that, where it says write the function rule for the table. You can just tell me, is it exponential or is it linear? Okay, so I'm only asking you to do 10 of these. I do ask that you do it on your own piece of paper or a Google Doc, and then you can send it to me either on Google Classroom or via email, and I'll enter it in. As always, feel free to reach out with any questions you have. I really appreciated how last week there were several people who were stuck, and they reached out and let me know. So I was able to make some adjustments and kind of go from there. So I hope you're doing well. Make sure you communicate if you have any questions or anything going on, and I look forward to hearing from you. Thank you.